Okay, let me add a short addendum about user-defined functions. So we've seen a couple of examples of them, and in fact I'll click back here briefly. We pretended that there existed a user-defined function called overlaps and a user-defined function called the length of the overlap. And I wanted to point out, at least in this context, or especially in this context, that you can indeed define these kinds of application-specific operations. Okay, so they're called UDFs, and you can, as a user, you can write one of these things. You can register it in the database, and then you can call it from within your SQL statements, and you can assign it. You can grant permissions for other people to use it as well. Okay, so the database becomes kind of a repository of user-defined functions that can be called from anywhere. And so there's three types to be aware of. One is scalar functions, the other is aggregate, and the third is table functions. And you can tell what they are by how they're used within the SQL statements. So a scalar function will appear pretty much anywhere any expression can appear. So if you can add two attributes together, or you can subtract them, or do any kind of arithmetic, you can apply a function. So this can appear in the select clause, or can appear in the where clause, or can appear in a join condition. It can appear sort of anywhere an attribute can appear. Okay. An aggregate function appears in the select clause only and is always associated with a group by. And so here I've kind of indicated perhaps a common aggregate function that users define when it's not available built in, and often this one isn't, is concatenate. So if you have a table of identifiers and words, and you want to concatenate all the words together to make one long string, that's not always something available built in, but it's a very natural thing to want to do, right? So I've got a set of small strings, and I want to create one long string. Well, concatenation is something that's very easy to do in most programming languages, and that's how you would express it in SQL. You would do a group by, right? You say, this example is a bit abstract to maybe go through live by waving my hands a lot, but if you've got some grouping attribute which defines a set of related strings, maybe I want to concatenate them all together. And so you might define a user-defined function to do this concatenation built from a string primitive that's just append, append, append. You know, if you have a function that can concatenate two strings, you can build a user-defined aggregate that can concatenate many strings. Okay. Fine. And then table functions appear in the from clause, and they're arguably the most complicated. So the most common example you'll see here is some kind of a table function that will allow you to define a sequence of integers. So sequence from 5 to 10. If you want to represent all the integers from 5 to 10 as a table, you know, one thing to do is actually physically create a table on disk and insert those integers into that table. But that's a little bit wasteful, right? Because we sort of know what that sequence should be. We don't actually need to physically store it. 5 to 10 maybe not so bad, but if you're trying to store the integers from 1 to 1,000,000, it can get worse. And so a function that knows how to generate these on the fly can be useful. And so you'll see table functions be used in this way. Now, well, I think this will appear on the next slide, actually. So support for these are pretty comprehensive. All databases have them, with unfortunately a notable exception being SQLite itself, which is the one you're using for the assignments. So I encourage you to go out and look at other databases, in particular Postgres and Greenplum, which is a commercial database that is parallel and based on the Postgres code base, has really, really excellent support for user-defined functions. SQL Server and Oracle and IBM all also have great support for it, but Postgres has a particularly clean interface and was really designed way back when with extensibility in mind. So it was one of the first, it originally was a research project, and one of the main goals of the research project was to show that an extensible database was a good idea. Things that where you could add your own functions, add your own types, you add your own features in various ways. Okay. And so in particular, support for manipulating time data, timestamps, is quite nice there. Okay, so you can define these user-defined functions in a variety of languages, including pure SQL, and you may have to sort of scratch your head to think about why that would be a good idea, but the short answer is that it's the same reason why defining functions is a good idea in any programming language, right? It's this notion of abstraction, okay, and reuse. Okay, and then there's programming language, imperative languages that are extensions of SQL, and Microsoft's got one called T-SQL, and Oracle's got one called PL-SQL, and Postgres has one called PL-PG-SQL that add things like we'll run a query and save the result in a variable and then reuse that variable later, or we can define variables of just primitive types like integers and reuse those. And there's usually also looping constructs and conditionals and every other kind of feature you might have in an imperative language. Okay. Fine. So these come up and they're useful, and if you're a database administrator or you have friends that are database administrators, they're going to be very familiar with these languages. I'm not typically a big fan of using them, not because I don't think they're a good idea, but because I find them to be overused. I think there's things you can do without having to drop down into writing an imperative program that are not always recognized. The other reason I don't like to use them is not for any kind of fundamental reason, just because the experience of writing code in these languages is actually kind of painful. They're difficult to debug because there's not great support for debuggers. When things go wrong at runtime, they're sort of hard to figure out what's happening, and so on. And so while I complain a lot when I see SQL logic being pushed into the application layer, I complain less when the alternative is to do it in one of these imperative extensions to SQL. Okay. So don't put your joins in the application, but you can put your loops. Okay. So fine. So in Microsoft SQL Server, any kind of CLR language from .NET can be used, and they're typically in C#, and so on. Python, there's an R extension to Postgres that I haven't had much of a chance to play with yet, but that's kind of exciting because it gets the folks that are interested in using databases with their statistics routines a much more compelling argument of how to do so. Okay. So that's what I wanted to say about that, and we'll see examples of user-defined functions come up in a few different places, and most importantly, they'll all use the term. And so I want you to know that the term comes from databases, and what I mean is just any kind of code that is not provided by the system itself. All right.